you doing?
I'm doing pretty well. How are you doing?
Good. Happy New Year. Can you still say that?
Yeah, I think so. Uh,
So you're a research professor at
yep.
Penn. Tell me about that role. What are your primary responsibilities?
So, I mean, the primary responsibilities are research. So, in general, I actually don't teach very much. The one exception is I do teach this blockchain course, but I don't teach any on-campus courses. I only teach in the MCIT online program.
Mhm.
Um, and so, yeah, my primary appointment is about doing research and so then getting grant funding to do that research. And I do research in sort of pure cryptography, so in privacy preserving algorithms, and then also in the blockchain space.
Can you, in simple terms,
Yep.
explain what blockchain is? What is blockchain technology?
Sure. So I think there's sort of different motivations, but so when Bitcoin came out, the idea of Bitcoin was basically to have a ledger that you think of as like a financial ledger, a list of transactions that's public. And the point of doing that was to say that if you have one person who's keeping this ledger, if you have a bank that's keeping the ledger, they get to decide what goes on the ledger. And what goes on the ledger is actually a transaction that happened. If I ask Bank of America to transfer some money to you, right, they choose ultimately whether they choose to decrement my account and increment your account. And that gives them this huge sort of monopoly power over my
Right.
ability to transfer money. And so if the idea is that money is basically just accounts in a ledger, whoever controls this ledger is in charge of things. And so now the question is, can you decentralize this ledger? Can we have a copy that no one person is in control of? And this is a really challenging thing because it's easy to make copies of a ledger. You can replicate data really easily, but you need to be able to update this data. How do you distribute the ability to
Mm,
write to this ledger in a way that you don't cause conflicts? Because if we each write, if I tell one person that I'm sending them $10 and I tell somebody else that I'm sending them $10, but I only had $10 to begin with, like both those transactions can't go through, right?
right.
So we need to have the data be kind of synchronized, but we want to have not just one person in charge of writing to it. And so the idea of Bitcoin was basically you replicate all the data and you have essentially a lottery where one person is chosen every 10 minutes to who gets to sort of write new transactions to this ledger, and then somebody else is chosen in a few minutes later. And so now you get kind of like a 10-minute monopoly. So like this block producer can choose a block of transactions, and when they are the leader, they get to choose any transactions they want to put on the ledger, but their monopoly is limited to 10 minutes. So they can't really abuse this monopoly power because they know they're going to lose their monopoly in a few minutes.
So is there one person that's controlling essentially the entire system for a short amount of time? Like 10 minutes, you said. Is that real?
Yeah.
Is that still
So,
how this works? There's one
uh,
I'm in
yeah.
charge of this for 10 minutes across
Uh,
the entire system?
Effectively, yes, in terms of sort of adding new transactions. So all of the idea of a blockchain is you really want to think a block is a blob of data. It's a list of transactions. And the simplest transactions are I am sending you some number of Bitcoin or I'm sending you some number of some other token. So it's a block is a list of transactions, and the blocks are organized in a chain and they're connected by cryptographic hashes, so you can't reorder the chain. And the question is, who gets to add the next block to the chain? And in Bitcoin, it's done by this proof of work lottery. And so every person who wants to participate can grab as many transactions as they want and put them in a block and say, I think these are the transactions that should be processed next. And then they try to sort of win this proof of work lottery. And if they win the lottery, that is their block that gets added to the chain, and everybody kind of accepts that.
I
In
see.
other systems that are proof of stake, it still works kind of the same way. There'll be like a stake weighted lottery or a round robin where one person is chosen and they say, you get to produce the next block. And we tell everybody, you're going to produce the next block. And everybody who wants transactions in the block sends their transactions to you. And you have unilateral control over which transactions make it in. And people usually will pay you some kind of fee to get their transactions in, or to get their transactions in first, or to get their transactions in at all. And there are no sort of official or legal rules around which transactions get in. You get to choose yourself. You can prioritize your own transactions. You can prioritize your friends' transactions. You can prioritize the transactions of people who pay you the most money. You can prioritize the transactions of your business partners. You can do whatever you want.
Hmm.
And you have the slot to make this next block. And then after that, it's somebody else's turn. And so in Ethereum, block slot times are 12 seconds. So every 12 seconds, there's a new block produced, and a new block producer makes that
I
block.
see.
Um, but yeah, but almost every blockchain works like that, that each block is created by one block producer. And when they are the block producer, they have complete control to put in any transactions they want.
So are messages sent when somebody becomes the new producer across the whole system? So it's my turn. I'm the producer. I'm the leader.
Yeah.
Is a message sent across the entire system to all the other, I guess,
Yeah.
participants, if you will, that I'm the leader?
So yeah, so it's a little bit different in the different blockchain systems.
Yeah.
So for a lot of systems now, it's nice to schedule things a little bit in advance. Bitcoin does not do this. Bitcoin is like an anomaly because they're still using proof of work. But for these proof of stake systems like Ethereum and Solana, there's a sort of a randomized leader rotation, and it's published a little bit in advance. There'll be a group of blocks called an epoch, and they'll say, here are the slot leaders for every block in this epoch. So we'll tell you,
Oh, I
you know,
see.
128 blocks in advance. Here's who's going to produce this block, who's going to produce the next, who's going to produce the next, and so on. And this gives you some ability to plan first if you are the block producer to plan and make any plans you want. And also for users who know they want to get a transaction in, it's nicer if they can send it directly to the person who's going to produce the block. So
Oh,
with Bitcoin and with the early designs of blockchains, there was what was called a mempool. Is I didn't know who's for Bitcoin, I don't know who's going to produce the next block. I send it to any block producer,
oh,
and they gossip it all around until my requested transaction is sort of known by everybody. And then somebody produces a block. And so, but if you can tell me in advance who's going to produce the block, I can save a little bit of bandwidth and send it just to that person,
I
right?
see. Okay,
Uh,
so obviously you mentioned Bitcoin, Ethereum. Are these cryptocurrencies, and is a cryptocurrency essentially one application of blockchain technology?
Sure, sure. So this is also, yeah, an important, I'm kind of like jumping into things here, but when Bitcoin was created, Bitcoin was a blockchain, and we're thinking of it as a ledger. And the only thing it keeps track of is who owns this Bitcoin cryptocurrency that it made up. And
Hmm.
so Bitcoin is the blockchain, and it's the name of the currency that it keeps track of.
Okay.
Okay. Now, other cryptocurrencies and other blockchains can do more. So Ethereum, when Ethereum was created a few years after Bitcoin, Ethereum is a blockchain, and it has a native currency called Ether that's on it. But Ethereum also allows you basically to write your own programs, which are called smart contracts, but they are just little programs. And Ethereum sort of built itself originally as the world computer. And the way you think of Ethereum is not just a ledger that's keeping track of account balances, but as like a really, really simple computer that's keeping track of state of all these programs. So you imagine you have like a really simple computer, like a 1980s style computer that's shared by everybody. And when somebody wants to run a little program, they can run it on this shared computer. And the thing about it being shared is that now the programs can talk to each other and they can interact. My program can interact with your program. And so on Ethereum, if you want to launch another token on Ethereum, I can write a little program that basically just keeps track of account balances for my tokens. If I want to create a token, Brett coin, I can just write a smart contract on Ethereum that has some functions that people can call. It'll have a transfer function. If you want to, you call this function on my little program,
Hmm.
it'll have like a balance of function, and you can call and ask, hey, what is my Brett coin balance? And
Hmm.
I write that implementation. And a token program, like you can imagine writing in Python or something, like a little program that has a simple database of people's account balances and has some exposed functions that people can call to update their balances, right? And it maybe does some checks to make sure that the balances are updated, according to whatever rules that I want. And so on Ethereum and on other blockchains that support smart contracts, anybody can create their own token by just writing a little smart contract. And so that makes it much, much easier to deploy new tokens. Like when Bitcoin was created, Bitcoin was the blockchain and the token.
Yeah.
And so you have to get people to install the Bitcoin software and all this stuff. And when people wanted new tokens, they would take the Bitcoin code and they would fork it. And so there are forks of the Bitcoin code like Litecoin, and Dogecoin is actually a fork of Litecoin. And so Dogecoin has its own blockchain. But now, if you want to make a coin like Dogecoin, if you want to make a meme coin, it's super duper easy to make a meme coin on Ethereum or Solana. You just write a little contract. And this contract code is basically already totally standardized. And so you can just like essentially like push a button and deploy a new token on Ethereum or on Solana. And so people who want to deploy meme coins like Dogecoin now, there's a marketplace on Solana called pump.fund that's very popular,
Mhm.
and they are deploying over 10,000 meme coins a week. Like they're deploying thousands of meme coins every day. And they've just made it, you just press a button and it doesn't create a whole new blockchain. They're all running on Solana. It's just a tiny little program on Solana because the program doesn't need to do very much. It just needs to keep track of the balances of this meme coin.
How many cryptocurrencies are there? Different kinds of cryptocurrencies, and why do some rise and fall in popularity? So now Dogecoin is
Yeah.
popular, but why
Yeah.
is it popular for users? I mean, is I know the technology is
Yeah.
is different, but what causes this?
Yeah. Okay, so that's a complicated question. So there are a lot of different blockchains, and all of the blockchain code is open source. So I can take the Bitcoin code and I can fork it, and I can change a few variables, and I can have something running in parallel to Bitcoin that will now have different account balances because it has a different history than Bitcoin, but it's running fundamentally the same
Right.
code.
Okay.
Um, but so there are forks of different chains. Then there are different chains that have, fundamentally different consensus algorithms and different rules and different execution environments. So there's like Bitcoin and Ethereum and Solana and Avalanche, and these are blockchains that are popular blockchains. And there are dozens, if not hundreds, of these sort of popular, what are called layer one blockchains that are like fundamentally different blockchains. But then these blockchains that support smart contracts, like pretty much almost every blockchain except for Bitcoin, supports smart contracts and allows you to deploy new tokens on that blockchain. So like Solana is a layer one blockchain, and it has a native token called Sol that you use to pay for transaction fees on Solana. But then anybody can deploy new tokens on Solana. And I was saying there's, you know, thousands and thousands of meme coins are being created on Solana every day.
Mhm.
And so if you count all of these meme coins, which are themselves sort of fundamentally new tokens by some definition, are like if you call these all cryptocurrencies, there are probably millions of cryptocurrencies now because there are thousands being created every day. But most of these nobody really cares about, or they have some very short-lived
Yeah.
life cycle. Because the meme coins themselves, right, have no stated utility. Meme coins are kind of like a way of gambling. It's like you can buy this thing and hope you can find somebody to sell it to at a higher price, but there's no like purported utility. Whereas some of these other tokens, right, there's some claim of utility as like a utility token. So like Ethereum has a base currency called Ether, and Ether you use to pay for gas fees on Ethereum. So
Mhm.
again, we were talking about like a blockchain, you're creating blocks of transactions, and there's a fundamental limit on how big these blocks can be. You don't want them to be too big because then the computer can't process them fast enough and things. So the code will have some limit of how big a block can be, which is a limit on how many transactions you can process. And so to get your transaction on Ethereum, I send my transaction to a block builder who then sends it to a block producer. But usually I have to pay some fee to get in there. You're essentially like auctioning off block space. Ethereum has some limited amount of block space. So people want to use it, have to pay, and they pay in Ether, which means that as long as people want to use the Ethereum blockchain, there's some utility to holding this Ether currency. And so like there's potentially some value to this that gives it some monetary value. Whereas things like the meme coins, right, there's like it's just a speculative instrument. There's no underlying value there. And
I see.
Dogecoin too. Dogecoin started as a joke, and it basically is still a joke. right? And it goes up and down in price, and people can speculate on it, and it's sort of interesting to try to track the price, and it's an interesting data exercise to predict the price, and it's, you know, an interesting like programming exercise. Can you get Elon Musk's tweets faster than other people so that you can buy faster than other people, right? Like you
Right.
can, but there's no claimed utility for it. Like nobody's using it for payments, and it's not really like used for anything. It's really just for speculation. And then there were there was a big boom in these NFTs, these non-fungible tokens, where you
I
could put
remember
some
those.
art on the blockchain, and you could make some argument that there was some utility in that you liked this art, or that it was a status symbol to own
Hmm.
it, something like that. And so that's also a little bit different. But there's the blockchain itself is kind of agnostic. It's just keeping track of ownership of sort of digital objects. And whether those objects have some value is kind of up to you. Like whether you
Right.
think there's some status value to owning an NFT is kind of up to you in the marketplace. You could use these blockchains to keep track of real world assets, and then they'd have some real world value. So people have proposed things like, let's put, you know, title deeds on the blockchain, and you could say, you know, this will record ownership of this plot of land in the real world.
Hmm.
And then you could transfer it on the blockchain, and this would make it nicer to programmatically transfer, you know, land or to borrow against it or things like this. The problem with that is that the legal system doesn't recognize the blockchain
Okay.
ownership. Just because the blockchain says you own this parcel of land, if it went to a court, right, that may not hold up. What may hold up is actually the title deed that's
Yeah.
stored in, you know, some like county records office.
Hmm.
And so the fact that you can transfer this like digitalized token really easily on the blockchain doesn't help if the legal system doesn't recognize that that corresponds to the legal ownership of the land, right? And so there's been a lot of work to try to digitize these real things, but it is kind of a challenge because that requires some link to the real world that the blockchain doesn't have, right? Like the blockchain can keep track of this digital token, but the blockchain can't enforce that this digital token means you actually own this land.
Right.
That's the province of the real legal system.
Yeah.
Um, and so there are lots of different projects that have tried to digitize things like that with differing degrees of success. Uh,
So, what are some other interesting real world applications of blockchain technology outside of cryptocurrency?
mhm. So again, it's very good for sort of keeping track of things in a way that's kind of interoperable. So again, well, okay, actually, even stepping back. So one thing is you could use it for payments, and now people don't want to accept Bitcoin for payments. If I'm a retail store, I don't want to accept Bitcoin for payments because the price is so volatile, right? I don't know how to
Right.
price my coffee in terms of Bitcoin. But there are a lot of stable coins out there that are pegged to the US dollar.
Hmm.
Um, and the way a lot of these work is actually that there's a private for-profit centralized company that will take your dollars and they'll hold on to them. And every time you give them a dollar, they will issue you a stable coin
Hmm.
on the blockchain. And this stable coin will retain its value because this private company promises you can always redeem the stable coin for one of the real dollars that they're holding on to for
Oh, I
you.
see.
Okay. And so now you have to trust this company to do this, but assuming you kind of trust them, now you can send this stablecoin on the blockchain and you can pay very little fees and you can send it sort of very quickly. And people might use those for payments. Now, that's not currently not being used for payments on a large scale in the US.
Where is
But
it? Where is that being used? Where can I use stable coins to pay for things?
okay, so you can use it. There's some claims that in countries where their local currencies are not themselves stable, so places where there's been lots of inflation or sort of government instability. So a lot people talk about Turkey and
Hmm.
Argentina as places where it's not easy to get a US bank account, but you can open a blockchain account because anybody can open a blockchain account.
Hmm.
You can now transfer these stable coins back and forth. And the technology is very easy. Like I can install an app on my phone that stores my stable coins. And as a retail store, you can just put up a QR code and I can press a button and send to you. And it, you know, works as easily as Venmo or PayPal or whatever. but you don't, unlike Venmo or PayPal, you don't need a US bank account to make it work, right? It's just sending on the
Right.
blockchain. Um, Now, if you wanted to cash those stable coins out for dollars, you would need a US bank account to get the
Yep.
dollars to. But if you just are happy with the stable coins, you don't need any kind of account. You don't have to go through any identity verification, and you can be in any country. And so this is a use case that exists. It's hard to measure exactly how big it is,
Yeah.
right? But it's kind of a neat idea that you can use it for cross-border payments. And so people have said, look, this could disrupt things like Western Union. And, a lot of people are really mad at Western Union for the extraordinary fees they charge. And you say, look, I can create a wallet on one of these many blockchains and get some stable coins, and I can send back to any country I want, sort of essentially for free. And that's kind of a cool use case. It's not a huge use case right now, but it is a moderate size use case. Um, the places where they are being sent a lot is exchanges send them to each other because the crypto exchanges, so they're crypto exchanges, like in the US, Coinbase is the biggest. And that's like a link between your bank account and crypto. So if I wanted to go buy some Ether, I'd create an account on Coinbase. I would send Coinbase some dollars and they would let me buy. So they have a marketplace where I can buy some
Okay.
Ether. And now, if they want to send to some other exchange or to move money around, they can send, a stable coin, like USDC is a stable coin issued by Circle. And they can send that to another exchange to settle between exchanges. And so stable coins are used for exchange settlement sometimes. Stablecoins are also used for payments in different industries. I was talking to a guy in the watch industry, and he was saying that USDT, which is a stable coin, is commonly used for the purchase of sort of like luxury watches and jewelry if you're doing cross-border purchases. That this is really easy. It's much faster than a wire transfer, and you don't have to pay exchange fees, and you don't have to worry about the different bank accounts. That I can just send USDT to sort of anybody kind of instantly. And so there are some uses that currently the uses are not that broad. Like when you go into a store, it's pretty rare to see anybody who would accept a stablecoin. There's a lot of hope that, sort of in the future that will be easier because the payment rails are really pretty good. But yeah, that kind of adoption we haven't seen so much. So the first use case is kind of payments. Other use cases are keeping track of things. So I was saying, like, there are claims that you could keep track of real world stuff like, land or the title for your car or something. Now, the problem with this is that it's very hard to get the legal system to recognize that this is the official record.
Yeah.
So in order to do that, often there might be some real world company that custodies everything. So if you say, according to the law, there's some company that bought up all this land and then they issue tokens of it. And if you wanted to get the real title, that's the one that's registered in your county office, you would redeem your token with this company that was like holding it for you. So it hasn't quite decentralized things, but now you at least have this interface to the like real world,
Yeah.
or this interface to the law. And so there's these ideas of things like that, that you can keep track of real world things. Other real world things that you can keep track of that work pretty well is things that are issued by a single person. So like tickets are an example that people talk about a lot. We haven't seen a lot of good use cases for this, but people have pushed this forward, of like concert tickets or airline tickets or something, that if I am, a concert venue, I issue tickets. And if I issue them as tokens on a blockchain, then people can buy and sell them very easily. Maybe I want that, maybe I don't, right? But if I did want that, this idea of having tickets that can be easily transferred and can easily be sold and not counterfeited is kind of nice. And then when they come to my venue, they have their app they have their crypto wallet on their phone, and they just transfer the ticket back to me and I let them into my venue, right? And now we don't need any interaction with the law because it's not a legal question of like really whether they own the ticket. I just, as the bouncer at the door, I just need to check that they had the ticket, right?
Right.
And so that whole interaction is kind of between me and the ticket holder. But the nice thing about putting it on the blockchain is that you can now have a secondary marketplace and people can transfer really easily. And maybe you, again, maybe you want that, maybe you don't. Because it's on the blockchain, you can add all kinds of programmatic checks. You could say it could only transfer this many times or something like this. Um, but this kind of idea is sort of interesting of like other things you could kind of keep track of on the blockchain. Um, you can, because the blockchains now like things that blockchains that support smart contracts, you can write any kind of programs. You can write simple kind of games. And so
Mhm.
you can keep track of in-game stuff. And by issuing those as tokens, there was a lot of talk that you could make these sort of transferable, right? So for some popular non-blockchain games, there are marketplaces where you can buy skins or you can buy, in-game items or something like that. If these were on the blockchain, sort of those marketplaces would be really easy. Like the game could issue me some super powerful sword and I could maybe trade it.
Mhm.
And sell it easily on the blockchain. And then the game itself could verify the ownership of when somebody comes to play that they're now the owner of this sword. Again, these things haven't panned out as much as possible, but these were the kind of the ideas that people have talked about as things you could kind of keep track of on the blockchain. Um, yeah. Um, but
So,
basically, it's good for creating marketplaces is really kind of the idea, I think.
yeah, that makes sense. What is cryptography and how does it relate to blockchain?
Yeah, so cryptography, initially cryptography as a field and was set up for just how do you do private communication. If you and I want to talk to each other in a way that some eavesdropper can't listen to, right? How do we encrypt our messages?
Yeah.
Um, and for probably a couple thousand years until the like 1970s or 1980s, this was like the whole purview of cryptography was just private messaging. In the last few decades, cryptography has expanded to include all kinds of things you might want to do privately. And with the internet, there's a lot of more sort of complicated private interactions you might want to have that aren't so nicely delineated of like, I'm good, you're good, and eavesdroppers are bad, right?
Hmm.
Like, so one of the big areas I work in is this area called secure multi-party computation. And this is the idea that you have a group of people, it could just be the two of us. We each have some data and we'd like to do some joint computation on this data, but we don't want to share the underlying data with each other, and we don't want to share it with some trusted third parties. So like imagine, one example that comes up a lot is say like in the healthcare space, we have different insurance providers and they have different views of people. So like
Hmm.
when somebody is my client, I've paid for their um, sort of all of their bills. And now when somebody is your client, you've paid for all the procedures that they've had. And people switch insurance providers. And so no one insurance provider maybe has somebody through their whole lifespan. That's like pretty rare. And you might want to do some analyses. You might want to ask a question like, is it cost effective for us to pay for a cancer screening when somebody's 20? Will that reduce the amount we have to pay for cancer treatments when they're 60,
Hmm.
right? But if I'm an insurance provider and people change insurance every 5 years when they change jobs or change states or graduate from school or whatever it is, very few insurance providers will have seen the same person, right? If you paid for it when they're 20,
Yeah.
you don't aren't the same one who's paying for it when they're 60. And so you can't run that regression yourself.
Hmm.
Right? And so we might say, look, let's get all these insurance providers together and they could join their data and we could run some regressions and see if on the whole this is a good cost cutting measure.
Hmm.
Right? But they can't just provide, nobody can just dump all of your private,
Yeah.
health records anywhere. And if you anonymize them first, then we can't link them because I need to know for this individual person, right? Did like somebody who got the cancer screening when they were 20, now how much should we pay when they're 60, right? And so you can't anonymize and randomize the social security numbers because then you can't join them. So one possibility is to have like a trusted third party where you sign a bunch of NDAs and everybody just sends their data over to this person and this person joins the data and then runs the regressions. But it turns out the crazy thing is you can actually do this with cryptography. You can do these kind of things called a secure multi-party computation
Okay.
protocol where we all have private data and we agree in advance, here is the calculation we want to run and here's the only calculation we want to run. We want to run this regression. And so we we agree on here's the code we're all going to run first. And we engage in a secure multi-party computation program. And now at the end, I can prove mathematically that the only thing you learn are the regression coefficients and nothing else about the underlying data is leaked to any of the parties.
So
Um,
you're sharing the code versus
the,
sharing the data.
yeah, and so the code we've sort of all agreed on, but the underlying data is very provably private. And so there are lots and lots of
Yeah.
areas people kind of want to collaborate with each other, but they are not either fully on the same team or fully sort of antagonistic to each other, right? So the initial thing where like we're just trying to communicate in private, it's like you and I, we are just totally on the same team and the eavesdroppers are bad and they're against us. But in this kind of more nuanced world, there's lots of people. We may be sort of in the same field and we have some stuff we want to work together on, but we also
Yeah.
have secrets that we need to keep from each other. And how can you do this cryptographically? And so this is like a lot of sort of modern cryptography is getting at this like much more nuanced kind of stuff. So I work a lot in the secure multi-party computation, and there are tons of applications of this kind of thing where you might want to join data sets, but keep the underlying data private. Um, then another big area of cryptography that's actually even more closely related to blockchain is what's called zero knowledge proofs. And so here, I may want to prove to you that either I know something or I've done something in a way without revealing what it is that I've done. So this gets used for credentials a lot. So like one actually cool use case for blockchain that again hasn't really taken off, but I think is like uh, uh, an opportunity is people have tried to build these kind of credential systems where you say like if I have a job from Penn, I would get a digitally signed, letter that says I'm employed by Penn, and I could get, maybe a digitally signed bank statement that's from my bank, and I can get a digitally signed driver's license from the DMV, and I would hold on to all these documents
Mm.
from these credential issuers. And then when I wanted to do something, when I want to go into a bar and show that I'm 21, I can present this digitally signed document. And now I might want to only prove some parts of it, right? I may, when I show the bouncer at the bar, I don't want to show them my address. I just want to prove that I'm over 21.
Right.
So I can use cryptography. If everything is digital, I can actually prove I have a driver's license. It hasn't expired yet. It was signed by the state of Pennsylvania, and it says my birthday was more than 21 years ago, but I don't have to reveal anything else. And so this kind of sort of privacy preserving credentials is kind of cool. So I can prove to all kinds of systems that I have that I'm sort of authorized to use them without revealing some of my authorizations. And so
Wow.
this can be things like from the real world where a credential issuer is digitally signed something. It also, the place it's being used the most on the blockchain is actually for privacy. So there are privacy preserving protocols for transferring. So on the blockchain, like Bitcoin and Ethereum and Solana and all the main blockchains today are essentially public, that you can see every transaction that everyone has made. And now they're what's called pseudonymous. The transactions are not associated with my name. You don't see Brett on the blockchain, but you see my address. And you may not know it's associated with me, but you can see every transaction this address has made. And if you can link, some part, one transaction to me, then
Yeah.
you can see my whole history, right?
Yeah.
There are a lot of analytics companies that are actually trying to tag addresses and say, actually, we can figure it out that this address belongs to, this person or this
Yeah.
company or something. And then you can see everything they're doing. And so you might not want that if that's, if you're making a lot of these transactions. So you might want to hide these transactions. And these zero knowledge proofs are actually a really good way to hide transactions. And so the way they're being used now is there are protocols where I deposit money and everybody can see I deposit money. And then later I will withdraw to a different address. And now I have to withdraw, the protocol needs to know that I deposited, right? I shouldn't be able to deposit $5 and withdraw $10.
Yeah.
So I have to prove to the protocol, hey, I deposited, if I want to withdraw $5, I have to prove I deposited $5 some other time, but I don't want to reveal which of the $5 I deposited, right? And so now I can get anonymity this way. And so the most famous of these was a protocol called Tornado Cash, but there are a bunch of other systems that sort of use this idea. There's a whole blockchain that preceded Tornado Cash called Zcash that used this kind of idea for private transactions. And the idea is, right, I can deposit publicly and withdraw publicly, but you can't link my deposit and withdraw because the linkage is sort of hidden by cryptography, by these zero knowledge proofs. And so there's lots of cool privacy protections you can get from that. And there's actually sort of a lot more on that topic, but there's a lot of cool cryptography that's going on there. For the basic blockchains like Bitcoin, there's two crucial things of cryptography that are being used all the time that are really sort of basics of cryptography. So one is these cryptographic hashes, which is a way to like have a cryptographic fingerprint of a piece of data. And so a blockchain, each block has the hash of the previous block. So it has like a little fingerprint that says, this was the block that came before me. And this is what keeps you from being able to rearrange the blockchain. And then there are digital signatures, and digital signatures are an authentication mechanism. You really think of them as like an analog to a real signature. Like when I want to write a check, I sign my name to it. And in principle, that keeps somebody else from writing checks on my account. And digital signatures are the like actually good way of doing that, right? Like how do I keep people from spending my Bitcoin? Well, you can only spend my Bitcoin if you can generate this digital signature, and only the person with the private key can do that. So I have a private key that corresponds to my Bitcoin or my Ether or whatever blockchain, whatever cryptocurrency I'm using. I can use, I have a signature scheme with a private key, and that allows me to make signatures. And that's how I convince the block producers that, hey, when this transfer actually came from me. So we were talking before is like, who's keeping the ledger, right? Like,
Yeah.
if you imagine Bank of America is keeping a ledger of account balances, but you don't want, even if it's just one person keeping the ledger, you still have to authenticate yourself, right? I don't want you spending from my Bank of America account. So Bank of America, the way it does it is I sign in with a password, right? Bank of America and I have a shared secret. But you can't have that on the blockchain because the blockchain has no privacy. So I can't authenticate myself to the blockchain by like saying, here's my secret password, because if the blockchain had my secret password, it would be available for everybody. So you need this public key cryptography where I have a secret key that allows me to generate signatures, and the blockchain is a public key that allows you to verify signatures. And so everybody can publicly verify that this message came from my account. And so then if I send a message that says, please send 10 Bitcoin, then you know it came from my account because it has a digital signature. And the cryptography is what makes that sort of verifiability and unforgeability. And so that's the sort of core cryptography that's sort of on all of the blockchains.
Brett, how did you get here? So you have a bachelor's degree in math,
Yeah,
you have a PhD in math,
yeah,
and you went to Brown.
yeah.
I'm actually, I forgot to mention, I'm from Rhode Island.
Oh, okay, cool.
Uh,
I'm from Boston. I loved being in Rhode Island. So I'm back. My mom lives like very close to the Rhode Island border now. So
oh,
yeah, I'm in that area some, and it's a great place.
so you have degrees in math. Tell me about your journey from math to its application in cryptography and blockchain.
Yep. So I was always a little bit interested in cryptography, and there's a lot of math in modern cryptography. It's very mathematical. And so I was really interested in number theory, which is the basis of a lot of kind of modern cryptography. And when I was in grad school, I ended up taking a cryptography class with Rafi Ostrovsky, who ended up being my grad school advisor. He was in the computer science department, but he had a joint appointment, so math students could take, his cryptography class. And I took that class, and it was super fun. And so even though all of my sort of coursework was properly like fully in the math department, I ended up doing more research with him, and he became my advisor. And so sort of almost all of my grad school research was in cryptography. So it was kind of a sort of straightforward transition from doing number theory
Okay,
to doing cryptography. And so now I've been doing mostly cryptography for a long time.
great. So I want to talk a little bit about the implementation of blockchain technology.
Yep.
specifically for folks who might be interested in getting into this space. How does one implement a blockchain system? Are there specific frameworks, specific tools? How does
Yep.
one implement this?
Okay, so there's a couple of things to separate first, which is there's the underlying blockchain client, which is fairly complicated. And so this is what's sort of processing transactions. And if you think of the blockchain as like keeping a state of the database, this is sort of like the underlying database code. And it also has a lot of networking that they're sending the blockchain clients are sending messages to all the other blockchain clients they know about. And so you probably like in my class, we don't do any implementation of these blockchain
Okay.
clients. You assume somebody is running a Bitcoin node, and the Bitcoin node client is written in C++, and or somebody is running an Ethereum node. There are a lot of Ethereum node implementations. You can get ones. There's one called Geth, which is written in Go. There's one called Reth, which is written in R. But you assume somebody else is running this Bitcoin client, and it's kind of keeping the state of the Bitcoin blockchain or the Ethereum blockchain. And then you want to interact with it. So like
Mhm.
there's a few ways you might want to interact with it. So there's one way to interact with it, which is as sort of an analyst, you might want to pull transactions off the blockchain and see what people are doing and see what currencies they're buying and see what NFTs they're trading or something. And there I would connect to an Ethereum node. And the Ethereum nodes have a publicly defined RPC where I can call and get transaction data back.
Mhm.
And I can do that using almost any kind of programming language that can make an RPC call.
Okay.
There are really nice libraries in JavaScript and in Python. And the reason, or sort of, these are two really nice ways to do this is because on the web, I might want to make a website that has a dashboard that shows here's the real time, Bitcoin transactions. And I would probably make that in JavaScript. And so my JavaScript on this page would connect to a Bitcoin node and pull transaction data and display it in a nice website. And so there's a JavaScript library called the Web3 library that allows me to do
Mhm.
that. As I don't make front ends that much, right? I'm more interested in analysis. If I want to say, how are people using a decentralized lending protocol like Aave, which is a series of contracts on Ethereum, and see how people are borrowing and lending, and are they making money, are they losing money, what kind of things are going on. I want to pull all of the historical data from the Ethereum blockchain. And that's nicer to do in Python than in JavaScript. So I use a Python library that's also called the Python Web3 library. And it's just a little wrapper for this RPC that's provided by all the Ethereum nodes. And so it's very nice. I can query and I can ask, what transactions were in this block, or, I can call specific contracts and I can read or write to them. So if I just want to read, what transactions were made, that's what I do most of the time because I'm interested in analysis. If you wanted to build a trading bot where you say, I'm, pulling in price data and I want to trade, you can also use this Web3 library to send data to contracts to
Okay.
say, trade, sell on my behalf or buy on my behalf or something. And your library would make a little digital signature and sign a transaction and send it to one of these nodes. So the Web3 library you can use to read or write from the blockchain. Um, and so that's what we use in the class that I teach. We use
Okay.
the Python Web3 library a lot to read and write to these blockchains, mostly to what are called EVM-based blockchains that use the Ethereum virtual machine. Um, and so that's like one way you'd interact with them. Then another question is, there are smart contracts on the blockchain themselves. So if you wanted to create a new token, or you wanted to, create a lending platform or a decentralized exchange or a little on-chain game or something like that, and you want something that's running on the blockchain itself,
Mhm.
the um, Ethereum, the Ethereum and blockchains that use the EVM, the Ethereum virtual machine, you write those smart contracts in a language called Solidity. And Solidity is very similar to JavaScript. And there are really nice environments for working with Solidity. And
My
then
next question was, what is Solidity?
yeah, all right, perfect. Um, so, right, so you can do a lot of blockchain stuff without writing blockchain contracts, right? So I just may want to use blockchain contracts, either to read from them or write to
Right.
them. But if I want to create my own contracts, then I would do that in Solidity.
Do you teach that in the course as well?
Yeah. So we write a bunch of our own contracts for simple exchanges and things like this, and some cross-chain bridges. So in the course, we focus on Python for like reading and writing to blockchains, and Solidity for deploying contracts onto EVM chains.
So you're also the director of the Crypto and Society Lab at Penn. Tell me
Yep.
about some of the projects you're working on.
So we've been working on a lot of different things. So some of them are blockchain based, and there I've been working with people at Wharton and at other business schools, and we look at there's a lot of really interesting sort of economics that are sort of being deployed on the blockchain. So the blockchain is kind of a cool space in that the data is public and people are creating new protocols with sort of different incentive mechanisms. And so they'll create a decentralized exchange that allows people to trade tokens, and it'll be set up in some ways about how it matches buyers and sellers and what fees it charges and what incentives it's using. And you get these sort of natural experiments where you can see here's the exchange and here's how they're setting fees and how people behave. And so there's a lot of really interesting like economics and mechanism design
Mhm.
questions, how you should design these cryptocurrency mechanisms. And so we do some stuff there looking at decentralized exchanges like Uniswap, like how they should set fees, looking at decentralized lending protocols like Aave, which allows you to borrow and lend cryptocurrencies. You put up one cryptocurrency as collateral, and you can borrow another. And
Mhm.
now you have questions of how should you set interest rates and how much collateral should you have and how should you handle liquidations. And all of these design decisions affect how people use the protocol. And now you can look at the blockchain itself and see sort of how people are using it and how many people are finding their loans being liquidated and how many people are putting way too much collateral that they're kind of missing out and things like this. So it's kind of interesting to sort of have both sides of the theory of like how you can have some simplified economic model of how you expect these things to behave, and then you can kind of verify on chain if it sort of matches your ideas. So that's like one direction of research. Another thing that's sort of similar is a lot of these blockchain platforms, in order to be decentralized, they want to say we have some kind of governance. So this comes about because if I want to create a decentralized exchange, I can write a couple of contracts and stick them on Ethereum,
Mhm.
and they will sort of run forever if I want them to without me touching them again. And so it's sort of I'm not in control anymore. But with any software project, you might want to update the software at some point, right? Like when new things come about, when things change, I don't want my software to be sort of sitting there and just running forever with no intervention. But if I keep the keys so that I can just update it whenever, then it's not really decentralized anymore because I could just change the exchange any way you want, and that might not be, you might not trust me to sort of be the good custodian of this exchange, right? I might just sort of pull all the money from it or something like this. And so people want to say, how do we have this kind of ability to stay current and update our code without having one person have the control of this? And the idea is often to decentralize through governance tokens. So a lot of these platforms will have a governance token that they distribute to people and that you can buy and sell in the open market. And then when they want to change the protocol in some way, there'll often be some kind of governance decision. And so on the blockchain, there'll be a vote of saying, should we increase interest rates or should we increase fees or should we deploy a new version of our contracts onto a new blockchain?
Mhm.
And there'll be an on-chain vote, and it'll be a stake weighted vote by how many governance tokens each person has. So it's like corporate voting on the blockchain. Um, and this is kind of interesting because you can choose, there's again a lot of different ways you can have voting mechanisms. Like there's not one way to aggregate votes, right? It's not like you just have to have votes and have majority votes. You can have all kinds of different things. And so people do a lot of people do what's called approval voting. Somebody proposes, yes, no, should we increase our fee from 3% to 5%, and then people vote yes, no on that. But a different thing you could do is you could say, what should the fee be? Everybody say, what we think the fee should be, and we'll take the weighted average of everybody's votes, right? Like that's a fundamentally different voting mechanism than having everybody vote yes, no on
Mhm.
this change, right? Some of these things use what's called approval voting, where you can approve of multiple options. So you can say the fee could be 3%, 4%, 5%, or 6%. And I vote and I say I'd be happy with 5 or 6%. And so I approve of both of those. And I don't split my vote for them. They both get my full vote. And then you count up, right? There's another form of voting. And so there's all these different kind of voting mechanisms. And you can imagine things like ranked choice voting, right? Of I say, this is my first choice, and my second choice is my third choice. And you can implement all of those really easily on the blockchain. And now you want to ask these questions. If you are a decentralized protocol and your goal maybe to either prevent malicious actors from taking things over, or your goal may be to sort of tap into the wisdom of the crowds to figure out what's the best setting of parameters or something like this, which of these voting mechanisms you should use. So this is also kind of a mechanism design question that sort of touches on a lot of like political science kind of research, where there's been a lot of study into these voting systems, but it's hard to deploy them in the real world, right? It's hard to imagine sort of the US presidential election being like ranked choice voting, but it's really easy to deploy a blockchain governance contract that does some kind of ranked choice voting and then see what people do. So it's like a really cool area for mechanism design and actually getting data.
Interesting.
Um,
Where is blockchain technology headed in the next 5 to 10 years, and what are you excited about?
so right, nobody quite knows where it's headed. And in the 15 years since the Bitcoin white paper, like
Hmm.
there have been a huge number of promises that haven't like quite come about. But the underlying tooling is getting so much better. Like, so this is one thing that we see like in the class that I teach. It's really nice that when we have people interact with the blockchains, the development environments and the sort of tooling that you use to interact with these things has gotten
Hmm.
so much better. And so it's getting closer and closer to being sort of easily usable for lots of people. Everybody has their own predictions of what's going to happen. One of the things I study a lot actually is stable coins and how people are using these kind of stable coins. And so, it is plausible to believe that you could have a real increase in stable coin transfers in the future, that this is like a really easy mechanism that would be easy for retailers to implement and is really easy for peer-to-peer transactions and for cross-border transactions and things like this. So that's a real possibility. I think there have been a lot of these promises of trying to tie real world stuff to the blockchain. Those sort of have never come true yet, but at some point they might, and that would be actually really cool as a way to sort of move forward of digitizing certain records. If you digitize them as sort of on a blockchain, then it's much easier to make sort of in different kinds of interfaces and marketplaces that you can use to transfer these things. So then there's all kinds of like, as a researcher, I'm also interested in the underlying kind of technology a lot. So, my background is in cryptography, where we
Hmm.
focus a lot on privacy. And most of the blockchains now offer very little privacy. And so there's lots of sort of really technical questions that are super interesting about how do you incorporate sort of more privacy into a blockchain, and how do you, increase scalability and things like this that are sort of fundamental technical questions that are really kind of interesting in their own right.
So, what advice would you give to students or professionals interested in entering the field of cryptography and blockchain?
Um, yeah, that's a complicated thing to actually.
Do they just take your course?
I mean, I think if you're interested in the blockchain space, the course, I've tried to make it a really good introduction to sort of a lot of the crazy stuff that's happening in the blockchain space,
Hmm.
plus up of this kind of technical meat of like how you can actually get in there and see how data is stored and interact with it. Um, and so, yeah, I mean, I've tried to make this a really good course. Unfortunately, because it's a short course, we can't go into the cryptography side a lot, which is too bad. We can cover the kind of basics of cryptography that you need for the blockchain. And so I was saying these fundamental things are sort of cryptographic hash functions and digital signatures,
Hmm.
but we can't go into a lot more of the kind of richness of cryptography around that because we just don't have the time. And there's so much happening in the blockchain space. But I do think essentially privacy is super important, and with the rise, as more and more things are digitized, as more and more things are videoed, as AI makes it easier and easier to sift through mountains of data,
Hmm.
having things that actually protect your privacy is super important. And so I would love to see more people kind of think more about privacy. So both thinking about the kind of tools that how do you build privacy into systems, but also how do you incentivize privacy and how do you get people to use kind of privacy preserving protocols. Like this, I would love to see sort of more of this, not specifically in the blockchain space, but just sort of in general. I think this is like really relevant right now. And clearly the blockchain space though also right now is really kind of booming again. And there's a lot of hope for doing really interesting stuff. And there's always interesting and crazy stuff going on the sort of financial side, on the
Yeah.
mechanism design side, on the engineering side. There's a lot of really fun stuff happening.
So where would somebody go if they don't go to Penn? They can't take your course. What kind
Yeah.
of training resources could you recommend?
So there are a lot of really good resources. If you like videos, there are a lot of really good resources on YouTube. I've tried to collect some of them on my website. So a bunch of places have put some of their basics of blockchain classes on online on YouTube. There are now more and more sort of like programming tutorials, and LLMs are making it easier and easier to kind of jump into getting something that kind of
Yeah.
works. There's still a question about on the privacy and security side of things, right? That they're not sort of exactly where you want them to be, but in terms of being able to sort of experiment and deploy some stuff,
Mhm.
it's great for just sort of helping you along with syntax that may be a little different than what you're used to. Like you can really kind of jump into things quickly. Um, and Unfortunately, I would say that like, if you blindly go to YouTube and look for crypto stuff, you find a bunch of people shilling their coins, and it's like a really kind of sad and depressing place to be. But
Yeah.
if you can find a couple of good content producers, like there's people who really are trying to teach you the kind of underlying technology, and that content is there if you can and find it.
Hmm.
Um,
Great.
yeah,
Well, thanks so much. This was fantastic.
yeah, it's good talking to you.
I learned a lot.
Yeah, thanks.
Have a great weekend.
Yeah, you too. Thanks.
Okay, bye.
Bye.